Question 5. How does the position of an element related to its electronic configuration? We talk about chemical reactivity. Alright, chemical reactivity comes down to the number of electrons in outer shell. It depends on your group number, right? Okay, so there are two ways you can look at position in the periodic table. Group, okay, so there's up and down, and then period, so there's left and right, right? Left, right, up, down. Okay, and you want to relate it to electronic configuration. Okay, now let's go through period first. So across the period, each element fills in with one extra electron in the atom, okay, due to increase of one proton as well. All right, but we want electronic configuration. All right, that means they continuously fill in different groups, i.e. One outer shell electrons means fill in group 1, and then two outer shell electrons means fill in group 2, etc., and so on and so on. Okay, how is the position related to the electronic configuration? So the position, so the group number, so I already told you that the group number will tell you the number of the outer shell electrons, right? Okay, the period number in which you fill it in, the period number of the element indicates how many inner shell you have, how many fill inner shell are there. Because let's say when you get to sodium is after neon, right? So and it's third period, so that means you must have two inner shells that are completely filled before you even go to the third period, right? So that means you have 2 and 8. 2 because you can fill 2 electrons in the first shell, so that's from hydrogen, helium, and then you go all the way from lithium to neon, so there's your second shell, and when that is full, only then you go to the third period. That's why when sodium is the first element in third period, the period tells you how many inner shells that have already been filled, but it's also in group 1, so the group number tells you the number of outer shell electrons you have. So again, position here refers to two things, the group and the period. What do they want you to do? Describe what does the group number tell you. Describe what does the period number tells you. Okay, so there are two factors there. You're not looking just at the outer shell electrons, you're also looking at the period number as well. So that's what is meant by periodicity. Yeah. All right, next bit. Aluminium is an element in group 3, so you want the aluminium ion. So if you look at aluminium, it is in the third period. Okay, so that means there are two inner shells that have already been filled. So when you go the first shell is going to be 2 electrons because it filled up to helium. So we're playing the ladder snack. Have the periodic table in front of you, and you will see that hydrogen, helium, then you go to the second shell, so go lithium all the way to neon, so there's 8 electrons in the second shell. All right, because we know it's a third period, okay, and we know it's group 3. Group 3 means there are 3 outer shell electrons. First shell, second shell, because you are third period, your 2 inner shells are completely filled, 2, 8. Okay, you are the third element in period 3. First shell, second shell, third shell. Okay, you are the third element in period 3 because you're in group 3, you have 3 outer shell electrons. In reality, this is something you can get by understanding periodic table easily. Yeah. Okay, so it comes natural to me, but it really depends on whether it comes natural to you or not. You need a bit more practice and understanding of the concept. Yeah. Next bit, aluminium reacts with oxygen. Most common mistake, people will write, well, students I say, will write just oxygen atom. You know oxygen is molecular oxygen, right? I tell you, this paper actually give you some hint, yeah? They started off by asking you something about diatomic earlier, right? So you really know that some molecules are diatomic, okay? Sometimes questions, the idea is there. You just need to pick up the hint from time to time, yeah? They form Al2O3, so you should know this formula because it comes in electrolysis. You know, electrolysis of this, when you extract aluminium, so you got to know the formula of the cation and anion. The LCM between 3 and 2 is going to give you 6. LCM because it is lowest common multiple from primary school mathematics, okay? LCM is going to be 2 times 3 is 6. So to get to 6, you need 2 of the Al. To get to 6, you need 3 of the oxygen. Only then you will have 3 times 2 will give you plus 6. 2 times 3 will give you minus 6. Plus 6 minus 6. No charge overall in the compound. Balancing equation. 2 aluminium on the right, so I need 2 aluminium. I cannot have Al2 there because aluminium is a metal. It has giant metallic structure. It doesn't exist as a diatomic molecule. Yeah? There's 3 oxygen there. If you have seen my other video, you know I love fractions. This is O2, you cannot change it. 3 over 2 times 2 will give you 3. I need 3 oxygen, right? So 3 over 2 times 3 give me 3. They don't need stat symbol. If you really want, you could have multiplied the whole thing by 2. You just get 4, 3, and 2 then. Both are perfectly correct because the formula is correct. The equations are balanced. Alright, there's nothing wrong with 3 over 2. Okay? Well, unless your teacher doesn't like it, then I don't know. I mean, both are perfectly fine, yeah? Okay, the examiner cannot penalize you if your equations are balanced and you get the correct formula. And yeah, okay. Aluminium oxide reacts with both acid and alkali. So this is known as amphoteric oxide. Alright, so you can define amphoteric oxide as well. And now they want you to draw a dot and cross for oxygen. So I think I mentioned earlier about the chlorine and chlorine single bond in question 1, so you can rewatch what I mentioned. But this is a double bond, a covalent bond. So each line represents 2 electrons, okay? It represents this. There is 1 pair of electrons being shared, 2 electrons being shared. I have double bond, so I have that. In reality, the electrons are the same, but I'm just drawing it dot and cross as they require to differentiate it. If you draw that, there's display formula, you wouldn't get anything. From that, you can get this dot and cross, and you will also not get anything because oxygen is in group 6. It has 6 outer shell electrons. It has used 2 for bonding. This one has also used 2 for bonding, so it still has 4 more. Because 6 minus 2 that has been used, you still have 4 more electrons that are not used for bonding, and you have to draw all the outer shell electrons to get the complete dot and cross. I wouldn't start from this usually. I would start from my display formula and I can convert it to dot and cross easily. Okay, these are same electrons because they belong to the same atom, whereas here they are being shared. That's why I have different. Now the other question is, do you want to draw shell or no shell? That is subjective. I do not like shells. That is me. I have always not liked shells, but I was taught shells as well back then. So I guess both are equally correct. I've shown it very neatly. It's really up to you, okay? It's really up to you whether you want shell or not. It doesn't make a difference at all. Now, describe and explain the difference in the rate of diffusion. So you need to describe and you need to explain as well, okay? So the gases, oxygen and nitrogen. So the gases are diatomic molecules. So both of which are diatomic molecules, meaning to say O2 and N2, diatomic, yeah, 2 atoms in 1 single molecule. The MR of O2 is going to be 16 times 2 is 32. The MR of N2 molecule is 14 times 2, which is 28. So you can tell that the oxygen is actually heavier, right? So O2 has higher MR than N2, meaning to say it is heavier O2. Therefore, N2 will diffuse faster, or you can say the rate of diffusion is faster for N2. It's comparison of their relative molecular mass. Yeah. You need to write the symbol. So based on whatever is given here in the periodic table, forms a stable ion of the type X2-. The 2- indicate that it has gained 2 electron. It forms a stable ion. So when you gain 2 extra electron, you get the noble gas configuration, which is why it's a stable ion. So we are looking at a group 6, because when you are group 6, you gain 2 electrons. You like to gain 1, 2, and then you get noble gas configuration. They say write the symbol for n element, so just one. So you have 3 choices there. You can just pick any one of them. You could pick sulfur or selenium, they will still be correct there. And they just don't want the symbol, you don't need to put down the name. A light green gas at room temperature. So you know the halogens are colored gases, as particularly chlorine, bromine, and iodine. This is a gas, liquid, and solid at room temperature and pressure. So this is atom. This is element in the periodic table. They are shown as atom. In reality, the group 17 exists as a molecule because they have simple molecular structure. They exist as a molecule like that. Okay, so chlorine is the symbol of the element. I do not put down Cl2, even though I know Cl2 is the pale green gas, dark orange brown liquid, gray black solid. Okay, but they want the symbol of the element in the periodic table. Next bit, forms an ion. So it forms an ion. It gives a yellow precipitate when you add silver nitrate. So that yellow precipitate is silver iodide. So we're looking at I-, but it says it's the element that forms the ion. So we're looking at iodine. Again, not I2, not I-, but the element itself, iodine. Okay, it's used to make food containers. So you can think about those food containers that you have. They're kind of plastic-ish. So we're looking at a polymer, which is from addition polymer, for example. So typically there will be carbon, and there's no hydrogen here, so therefore I wouldn't be looking for hydrogen at all, just carbon. It's a diatomic gas, forms 78% of dry air, so that is nitrogen, but you're not going to put down N2 again. It's the element, it's the symbol of the element, it's not N2. Okay, even though that gas is actually N2. Next bit, magnesium is a metal, so 2 properties. They did not mention chemical or physical. That means you can have physical, you can also have chemical property. Characteristic of most metals. So all metals have giant metallic structure. So all of them require breaking the giant metallic structure when you melt metal. So all metals have high melting point. What else can you say about metals? So it's a giant metallic structure. If you know the metallic structure, you will know that they have a sea of delocalized valence electrons, and they also have their cations suspended in that sea of delocalized valence electrons. So they all can conduct electricity. When solid or molten, they will have free electrons to conduct electricity. You can talk about malleable. So all metals are malleable. You can talk about all metals are ductile as well. So those are properties of metals. Complete the electron configuration of a magnesium atom. So there is 2 so 8 electrons in the second shell, and then 2 electrons in the third shell. Does it matter when you put 2 like that, or 1 there and 1 there, or 1 there, 1 there, or 1 there, 1 there? It does not matter at all. The electrons are always moving. What you show here is just at that point in time, the electron is there, but all the time the electrons are moving somewhere along this electronic shell. Okay, so you know that, right? Yeah. Okay.